4 kilojoules per mole at 298 Kelvin. Is right. Calculate the value of enthalpy change. Calculate the value of enthalpy change. Now, please listen here, guys. See, the first thing that you have to understand, we have the heat of combustion of methane gas at constant volume. If it is constant volume, then the heat of combustion is equal to what? Tell me, guys. If heat is measured in constant volume, then what are we measuring? Tell me. Look at the last class and tell me if Q is at constant volume, if you are measuring heat at constant volume, then what change in energy are we measuring? Are we measuring delta H or are we measuring delta U? Please look at this part and tell me. Where is constant volume? Tell me. A, B, C or D? कहाँ पे आपको दिख रहा है? Tell me. Constant volume. Where can you see constant volume? Tell me. Aisha, Fahad, Hiba, and Abdullah. Please tell me, guys. Yes, Fahad, correct. Hiba, आप बताइए. Where can you see constant volume? Yes, Hiba, very good. Aisha, tell me, where can you see constant volume? Aisha. Read and tell me, guys. Okay. See, here it is what? Change in volume is equal to 0. If change in volume is equal to 0, that means it is what? Constant volume. And at constant volume, we get delta U. See, in the last lecture, I also told you guys, what is delta H? Energy at constant pressure. What is delta U? Energy at constant volume. Okay. So delta U is always what? The energy at constant volume. So Q, when the volume is constant, this is equal to delta U. And what we need to find? We need to find delta H. Now, what is the formula? What is the relationship between delta H and delta U? We know the relationship delta H is equal to delta U plus delta NGRT. Now, do we have the delta U? Yes, we have the delta U. Do we have the temperature? Yes, we have the temperature 298 Kelvin. Do we have the R? That is the universal gas constant. Yes, we also have the R 8.314. Now, what about delta NG? What is this? The change in the number of moles of gases in products and reactant. Product or reactant to hai nahi. Now, for this, you need to write the reaction of combustion of methane gas. So, see, CH4 plus O2. This is from your first chapter. Okay, CH4 plus O2. So here what we are going to get, when carbon burns on oxygen, we get carbon dioxide. And when hydrogen burns with oxygen, we get water. Now you need to balance this equation here. You need to balance this equation here. You are going to use only 1 mole of methane. Okay, you are going to use only 1 mole of methane. And then you will balance it like this. So here you have how many hydrogens? There will be 2 H2O molecules because we have 4 hydrogen. And this will be 2O2. Is that correct? Yes or no? Please tell me, guys. Look at the balancing. Now, this is also gas. This is also gas. This is also gas. And what about H2O? H2O in its at 298 Kelvin, है ना? कैसे? 298 Kelvin मतलब 25 degrees Celsius में कैसा होगा? It will be in liquid state. It will not be in vapor state. It will be in liquid state. Okay. So 298 Kelvin, water will be in liquid state. Everything else is in gaseous state. Now, right, what is delta Ng? The number of moles of gas in product minus the number of moles of gas in reactant. How many moles of gas are there in the product? Tell me. Aisha, tell me how many moles of gas are there in product? Aisha, turn your mic on. Aisha, please turn your mic on. Aisha, am I audible? देखिए आप लोग जवाब नहीं दीजिएगा, है ना? आयशा, Others tell me how many number of moles of gas are there in the product. Tell me guys, number of moles of product. हिबा आप बताइए. How many moles can you see in product? Number of moles of gas in product, हिबा. हिबा दिख रहा है नहीं दिख रहा है?
Yeah.
How many moles? Can you see how many moles? या फिर आपको नहीं समझ में आ रहा है? Yes, हिबा.
So what?
How many moles of gas are present in product? Am I audible properly, Hiba?
Yes, sir.
So what did I ask?
The number of moles in the product. For
Number
gas.
of moles of gas
Yeah.
in. Number of moles of what?
Gas in the product.
Yeah. How many moles of gas are there in the product? What are the products? Tell me.
CO2 and H2.
Okay. So which of them is in gases form?
CO2.
And how many moles of CO2 is there? How many moles of CO2 will be there? If there is nothing, so what is the stoichiometry here, Hiba? If there is nothing here?
1.
One, no?
Yeah.
I hope this was not very difficult.
Mm.
How many moles of gas in product? How many moles of gas in reactant? Tell me.
3.
This will be equal to how much?
-2.
Delta H is equal to delta U plus delta Ng RT. You have the value of delta Ng, that is -2. The value of R, once again, I am telling it will be equal to 8.314 joules per Kelvin per mole hota hai. Okay, so you will get delta U. You have here. Convert this delta U to joules. Okay, this is kilojoules. You will convert it to joules first of all, and then you will write here what is delta U and the temperature kitna diya hua tha? Temperature was 298 Kelvin. Please send me the answer of delta H in terms of joule. The value of delta U is given here. This is Q, that is the heat, minus 885.4 kilojoules per mole. Fahad, am I audible?
Yes.
आपने वो redox का try किया था फिर oxidation number वाला?
एक करा था बस।
हुआ ठीक से?
हाँ वो हो गया था।
Devang is not present today. Write this down, calculate delta H and send the answers. आयशा, आपको हमारी आवाज आ रही है? यस आयशा? नहीं, ओके। What happened? आंसर किसी ने भेजा है -58. Hiba, can you please turn your mic on?
Yeah.
कितना वैल्यू आ गया इसका? Just a second. कैलकुलेशन में कुछ मिस्टेक है क्या? Because 2 into 8.314 into 298, that is equal to 4955, है ना?
0.14.
Sorry?
So it's minus 4,955.14.
No, that is correct. And delta U is what? Minus 885.4
0.4.
into 1000 भी तो है, किलो जूल है ना?
Oh, sorry, I didn't convert it.
Okay, this will be also in joules. So this will come out to be 89 minus में 890,355.144 joules, which you can write it as minus 890.35 kilojoules. Please write this down, everyone. Take a screen. Tarif, why are you so late? Yes, Tarif, how are you?
Fine, sir. How are you, sir?
I'm good. Alhamdulillah. Thank you. Why are you so late?
Sir, I had some internet issues, sir. So,
What did you have?
sir, internet issues, my
Issues,
Wi-Fi
okay.
cut off.
Jania, what about you? Have you revised the last class? Tarif?
Yes, sir.
Yes. What did we study? What topics in the last class? Tell me.
No, sir, last class I was not present.
You are not present. So did you watch the lecture?
Yes, sir.
Huh? Sorry?
No, I couldn't finish it full, sir. That's right.
Why? Wednesday was the last lecture. Today it is like it was on Thursday, na? Thursday was
Yes,
the
sir.
last lecture. It is Tuesday now. You should find time and then like I don't know what to say to you guys. Please take a screenshot, those who have not done. Please take a screenshot. We have just done a numerical on delta H is equal to delta U plus delta MGRT. Okay. So those who are late, please watch the first half an hour of this lecture. It will be uploaded tomorrow. Okay. Please take a screenshot, guys. I will wait for a few minutes. Devangi, you said you had some extra classes. Like you will be having extra classes daily?
No, sir, just today.
Okay, just today. Okay. Just take a screenshot for this one. And then we'll move to the next topic.
Done, sir.
Now, see, we have got two formulas for delta H. Initially, we had the formula delta H is equal to delta U plus P delta V. Okay, plus P delta V. And then from here we derived delta H is equal to delta U plus delta NGRT. From here we derived delta H is equal to delta U plus delta NGRT. Now, please listen. If you have a reaction in closed vessel, vessel where change in volume is equal to 0. Change in volume will be equal to 0 if this is the case. In the above example also, we said that the difference here is what? The heat of combustion of methane gas at constant volume is measured to. It is not saying that we have done it in this particular order, but we have measured this reaction we have measured the heat of combustion at constant volume. But if this reaction happens in a closed vessel where the delta V is equal to 0, then in that case, delta H, this would be equal to, see, here you have delta U, and here we have what? Here we have the P delta V, right? So delta V will be equal to 0. So delta H will be equal to delta U in this case. If you do the reaction in a closed vessel. Right, next. Reaction that does not involve gases. Okay, the reaction that does not involve gases. That means when you have number of moles of gas of reactant and it is equal to the number of moles of gas in the product, in this case also, delta H will be equal to delta U. Why? Because delta Ng will be equal to what? 0. Delta Ng will be equal to 0. Okay, write this down. Okay, there are two cases, delta, the reaction that does not involve gases or number of moles of gas in reactant is equal to the number of moles of gas in product. Sorry. In दोनों केस में delta H will be equal to delta U. Write this down. Now, see, we have all of these questions. They say that we have calculated the heat exchange. We have calculated the heat exchange, the heat of combustion. So when combustion happens, heat will be evolved from system to surrounding. And we have two things: we have system and we have surrounding. Please understand this concept very carefully. Let us suppose we have a small system like this. Okay, we have a system. Now, if system gives out heat, system is giving out heat, and here we have the surrounding, and this is what? This is your surrounding. Now, in this case, when system is giving out heat, then in this particular case, the temperature of surrounding will increase. Yes or no? Please tell me, guys.
Yes, sir.
Temperature of surrounding increases. And let us suppose if we are giving heat to the system, then in this case, temperature of surrounding decreases. Yes or no? Please tell me. Is that right?
Yes, sir.
That is correct. So what is happening? In the first case, we are giving out heat, so the temperature of the surrounding will increase. Okay, that is the only change that happens if the heat is involved. If heat is involved, then we can infer about how much heat is involved from what? From temperature. Okay, so temperature is the tool, or rather we can say temperature is that property that we are going to measure in order to infer about this heat. How much heat is involved? We will get that from what? We will get that from the temperature. Now, if I talk about two bodies, please tell me. If I talk about two bodies, I have here a small utensil and we have water. And I have here large utensil. And I have here large amount of water. I'm giving this Q amount of heat, and I am also giving this Q amount of heat. Okay, I'm giving both of them Q amount of heat. Now tell me, where will you see large change in temperature? In the A case or in the B case? Where will you see large change in temperature? In which case will you see large change in temperature? I'm giving the same amount of heat. Okay, आप इस तरह से सोचिए. You have your gas stove, है ना? And you have heated a small pan of water for 5 minutes, and you have heated a big pan of water for 5 minutes. So what do you think which is going to? चलिए boil करना है मान लो, है ना? So you have given 5 and 5. So tell me which is going to be having higher temperature? Where will you see the large change in temperature? A or B? Where will you see large change in temperature? What about others? बाकी लोग को नहीं आ रहा जवाब. अरे थोड़ा पानी जल्दी गर्म होगा या ज्यादा पानी जल्दी गर्म होगा? This is as simple as that. Please answer in the chat A or B. Aisha, Devangi, Fahad has answered. Hiba has answered. Jania, Tarif, and Muhammad Abdullah. Please tell me, where will you see large change in temperature? A or B? Okay, Tarif, correct. Okay. Devangi, can you please turn your mic on? Yes, Devangi. Can you please explain the answer? देवांगी, आपको सवाल समझ में आया? देवांगी, your mic is off.
यस सर, वो गलत टाइप कर दिया.
अच्छा, कौन सा पैन होगा, ए या बी? ए पैन होगा, राइट? ओके. अच्छा, क्यों ये जो आपका ए पैन है वो तुरंत ही हीट अप हो जा रहा है ना? इट इज गेटिंग हीटेड अप वेरी क्विकली. दैट मींस उसमें हीट होल्ड करने की कैपेसिटी नहीं है ना? If I am going to boil it off, for example, if I say I want to now boil it off, so this will require Q1 temperature, this will require Q2 temperature, and you know obviously Q2 is going to be what? Q2 is going to be greater than Q1, है ना? यानी कि if I have a large quantity of water, that can hold more amount of heat. Is that right? Yes or no, please tell. All of you understood this? The capacity to hold heat in a larger pan of water will be higher than in a smaller pan of water. Is that correct? Yes or no, please tell me, guys.
Yes, sir.
Correct? Okay. Now, this is known as heat capacity. Okay, this is known as what? Heat capacity of different substances. Please write heat capacity. Because as you saw now, I am giving same amount of heat. अगर हम सिर्फ temperature की बात करते हैं, in Q1 and Q2, I am giving same amount of heat. But the difference in temperature here is delta T1 and the difference in temperature here is delta T2. So, like, how can you say that you are seeing just a change in the temperature, but you have different change in temperature, but you have given same amount of heat? So obviously there is something missing here, and something that was missing in this particular equation was heat capacity. Since the heat capacity of A and B is different, we will see different changes in temperature, even though we are giving same amount of heat. We are giving same amount of heat, but still we are seeing what this is having 5 degrees increase in temperature, that is having 1 degree increase in temperature. So सिर्फ temperature पे हम नहीं छोड़ सकते. We cannot leave things just on temperature. We have to now also look at what new term, that is heat capacity, the capacity to hold heat. As simple as that, the capacity to hold heat, and this is given by, denoted by the letter C. किससे denote करते हैं इसको? C letter से denote करते हैं इसको. Okay, now see. We know that if you give more heat, there will be more change in temperature, right? There will be more change in temperature. If you're seeing a large change in temperature, that means you have given more heat. Now, in order to convert this to equality sign, we should have a constant, that is C and delta T. यही C क्या है आपका? Heat capacity. Now, what is C? C will be equal to Q upon delta T. Q upon delta T. Now, I want to do what? I want to define C, and C is a constant. And how to define a constant? Now, constant will be at one part. What you do? You just see, constant will have an equation will have LHS and RHS. Just look where the constant is. Constant it has is at RHS. RHS में whatever variable you have, you turn it to 1. ना? तो delta T हम लोग क्या करेंगे? Delta T is equal to 1. So when delta T is equal to 1, C will be equal to Q. So how will I define this? I will define this as heat capacity is the heat required by system to increase the temperature by 1 degree Celsius. 1 degree Celsius हमने increase किया, so this C will be equal to Q. So what is heat capacity? Heat capacity is the heat required to increase the temperature by 1 degree Celsius. To increase the temperature by 1 degree Celsius or 1 Kelvin. ठीक है? 1 degree Celsius का change हो ना? Change in temperature, if I talk about 1 degree Celsius is equal to 1 Kelvin. हम ये नहीं करेंगे 1 degree Celsius is equal to 1 Kelvin. I'm saying that if you are measuring change in temperature, then 1 degree Celsius is equal to 1 Kelvin. Okay. इस वजह से होता है क्योंकि if you see the scales now, if this is 0 and this is 1, तो 0 के corresponding क्या होता है आपके पास? 273 बोल सकते हैं, and 1 के corresponding क्या होता है? आपके पास 274. This is degree Celsius and this is Kelvin. If you look at this change and this change, दोनों बराबर हैं. Okay. So change in temperature, degree Celsius and Kelvin is same. Write this down. ठीक है? अच्छा. But when you talk about heat capacity now, here we are not telling one thing. For example, if I talk about heat capacity of water, if I take small amount of water and if I take large amount of water, to increase the temperature by 1 degree Celsius for A case will be different to increase the temperature by 1 degree Celsius for B case. Okay. So now we have to also add one more part, that how much, what is the amount of substance in the system that we are heating. So on the basis of that, heat capacity is of two types. Please write heat capacity and make branches for heat capacity like this. Specific heat capacity it takes mass as constant. Okay, mass in grams as constant. And then we have molar heat capacity. Molar heat capacity, it takes what as constant? Number of moles as constant. Takes a number of moles as constant. Now this specific heat capacity is equal to whatever heat capacity that you have measured, है ना, आपने 1 डिग्री चेंज करने में जितना भी हीट अमाउंट हुआ मेजर, उसको आपने मेजर कर लिया एंड यू डिवाइडेड बाय मास इन ग्राम्स. ओके, सो दिस विल बी इक्वल टू C क्या होता है? Q अपॉन डेल्टा T into mass in grams. This is standard heat capacity. Now, molar heat capacity is written as C with a subscript of M. So molar heat capacity will be equal to whatever heat capacity that you have measured. That means the heat change. आपने इतना बड़ा बर्तन लिया, पानी लिया, और उसको you measured what is the heat required. What is the heat required to change the temperature to 1 degree Celsius, है ना? Change the temperature 1 degree Celsius. So C upon number of moles. Then what you will do? You will calculate the number of moles of this water and you will divide it and you will get molar heat capacity. And then further we can write Cm will be equal to, C is equal to what? Q upon delta T into the number of moles. Please write this down. यहाँ पे एक नोट लिखिए, very important. Please see here, guys. I want to change the temperature of these two water bodies by 1 degree Celsius. अच्छा, इसको पहले बताइए, उसके बाद आंसर लिखिएगा, ठीक है? उसके बाद छापिएगा इसको. Now tell me, I want to change the temperature of A and B by 1 degree Celsius. Both are water. Which will require more heat? Tell me. A or B? Which will require more heat? I want to change the temperature by 1 degree Celsius, which will require more heat. अरे पानी गर्म करना है, ज्यादा देर कहाँ गर्म करना पड़ेगा? ए को गर्म करना पड़ेगा ज्यादा देर या बी को? 1 डिग्री सेल्सियस चेंज करना है ना? बी को चेंज करना पड़ेगा. अच्छा, प्लीज लिसन वेरी केयरफुली. This heat required to change the temperature by 1 degree Celsius, this Q1 will be the heat capacity for A and this Q2 will be heat capacity for B. Yes or no, please tell me. This will correspond to C1 and C2. Is that right? Yes or no, please tell me. है ना? अरे हाँ ना प्लीज बोलिए ना, माइक ऑफ. हाँ ना बोलिए प्लीज. Yes, Devangi, Fahad, Hiba, Jania, Tarif and Abdullah, please tell me. The heat that is required to change the temperature by 1 degree Celsius is known as heat capacity. Obviously, C2 will be greater than C1. Yes or no, please tell me. कौन बड़ा होगा? C2 बड़ा होगा because C2 is requiring more heat. Correct है?
Yes, sir.
Yes, sir.
Now, but please remember, अब यहाँ पे देखिए, mass ज्यादा हो रहा है तो heat capacity ज्यादा हो रही है. That means heat capacity क्या है? Extensive or intensive? Tell me. Heat capacity is dash property. Extensive or intensive? Tell me, guys. बताइए. मास बढ़ने से हीट कैपेसिटी बढ़ रहा है तो एक्सटेंसिव हुआ या इंटेंसिव हुआ? भूलिए सर. सॉरी, once again.
Extensive.
Very good. It will be extensive property because extensive. ठीक है. But right next. अब देखिए C1 अपॉन C2 है, इसको आप डिवाइड कीजिएगा M1 और इसको डिवाइड कीजिएगा M2 से. Now obviously tell me कौन सा ज्यादा बड़ा होगा? M2 बड़ा होगा, M1 छोटा होगा, right? C1 is also small, M1 is also small, है ना? Their ratio, C2 is also big, M2 is also big, so their ratio, both of these ratio will be now equal. Okay, both of these ratio will be now equal. And what is this? C1 upon M1, it is specific heat capacity. We'll write, but स्पेसिफिक हीट कैपेसिटी एंड सिमिलरली अगर हम नंबर ऑफ मोल्स लिख दें तो नंबर ऑफ मोल्स 2 का ज्यादा होगा, हीट कैपेसिटी भी ज्यादा है तो उसका रेशियो, और कम हीट कैपेसिटी एंड कम नंबर ऑफ मोल्स का रेशियो भी बराबर होगा. बट स्पेसिफिक हीट कैपेसिटी एंड मोलर हीट कैपेसिटी आर इंटेंसिव प्रॉपर्टी. Let me know if you're done, guys. Right, next. Now, this was the classification of heat capacity on the basis of measurement of amount, whether we are measuring the amount in moles or in mass. Now, heat capacity is also classified into two categories. On how we measure the heat capacity, please write heat capacity. We can measure the heat capacity at constant volume. Or we can measure the heat capacity with pressure constant. है ना, दो ही चीज है, या तो pressure constant रखिए या तो volume constant. Now, when the volume is constant, this heat capacity is known as CV, and when the pressure is constant, it is known as CP. ठीक है, CP and this is CP. अब देखिए क्लास, प्लीज ध्यान से देखिए क्या है यहाँ पे, वॉल्यूम इज कांस्टेंट एंड Q V will be equal to CV into delta T, है ना, and the heat, the exchange of heat, the involvement of heat, the transfer of heat at constant volume is equal to what, delta U या delta H? Tell me, guys. Heat exchange at constant volume is equal to delta H या delta U? जी बताइए, डेल्टा एच, जोर से बोलिए, माइक ऑन करके बोलिए, डेल्टा एच और डेल्टा यू. हीट एक्सचेंज एट कांस्टेंट वॉल्यूम इज डेल्टा एच और डेल्टा यू? सब भूल गए, अभी पढ़ाया है हमने. प्लीज लुक एट द लास्ट क्लास एंड टेल मी द हीट एक्सचेंज एट कांस्टेंट वॉल्यूम इज इक्वल टू डेल्टा एच और डेल्टा यू. किसी की आवाज नहीं आई अभी तक, प्लीज टेल मी द आंसर्स, गाइस. देवांगी, फहद, हिबा. The heat exchange at constant volume is equal to delta H or delta U? बाकी लोग को नहीं आ रहा, फहद ने आंसर किया है. ठीक है हिबा. देवांगी, व्हाट अबाउट यू? जानिया, तारीफ, अब्दुल्ला. साहब पढ़िए, आप लोग पढ़िए, ठीक है. देवांगी क्या नहीं आंसर आ रहा है? देवांगी टर्न योर माइक ऑन.
डेल्टा यू सर.
डेल्टा यू. क्या हुआ, इतना लेट क्यों देवांगी? आप माइक भी नहीं ऑन कर रहे थे, कुछ नहीं. यस देवांगी, अरे फिर कुछ नहीं बोल रही हैं आप.
सर वो कंफर्म कर रही थी नोट्स में.
I don't know what happened to this eraser. Wait a second. Just a second, guys. This will be equal to delta U. Heat exchange at constant pressure, this will be equal to Cp into delta T, and this will be equal to what? Tell me, guys. Mic on करके जल्दी बताइए. heat exchange at constant pressure is equal to heat exchange at constant pressure is equal to अरे भाई साहब इतना ढीठ हो गए हैं आप लोग, किसी का माइक ऑन नहीं हो रहा है। हीट एक्सचेंज एट डेल्टा बंद कर देंगे, हम पढ़ाना बता रहे हैं। रिस्पॉन्स ही नहीं आता आप लोग का बिल्कुल। रिमेंबर दीज रिलेशनशिप्स, ओके, रिमेंबर दीज रिलेशनशिप्स। आपको यहाँ पे क्या दिया रहेगा, सीवी दिया रहेगा, ठीक है, सीवी दिया रहेगा आपको। आपको बस क्या करना है, सीवी दिया है आपको, आप इसको यू कैन कैलकुलेट द क्यूवी कैसे, सीवी अपॉन सीवी इंटू डेल्टा टी कर दीजिए, चेंज इन टेम्परेचर, यू विल गेट द क्यूवी, दिस विल बी इक्वल टू डेल्टा यू। ठीक है, तो आपको क्या दिया रहेगा, सीवी दिया रहेगा, है ना, और आपको डेल्टा यू वहां पे पूछा नहीं रहेगा, आपको पूछा रहेगा डेल्टा एच। सो यू शुड रिमेंबर दीज थिंग्स कि सीवी से हम डेल्टा यू कैसे निकालेंगे, डेल्टा यू से फिर डेल्टा एच हमारे पास कैसे निकलेगा। ओके, सो प्लीज रिमेंबर दीज रिलेशनशिप्स। बट आप देखिए ना कितना सिंपल है, हमने आपको बोला था लास्ट क्लास में, दिस इज द मोस्ट इंपॉर्टेंट थिंग दैट यू विल रिमेंबर, जो यहाँ पे था, this one delta H is equal to delta U plus delta Ng plus RT। इतना अच्छा से लिखा है, एनर्जी एक्सचेंज एट कांस्टेंट प्रेशर डेल्टा H, एनर्जी चेंज एट कांस्टेंट वॉल्यूम डेल्टा U। अब यही चीज बार बार हमेशा आती रहेगी, ठीक है, अलग अलग तरीके से वो बताएंगे, है ना। पहले उन्होंने बोला कांस्टेंट वॉल्यूम में करेंगे, फिर उन्हें क्या बोल देंगे वो, दे विल से दैट हीट कैपेसिटी इज इक्वल टू सीवी, सीवी का वैल्यू दे दिया आपको, और आपको डेल्टा यू निकालने के लिए, डेल्टा यू तो डायरेक्ट नहीं बोलेंगे, वो बोलेंगे कि डेल्टा एच निकालो, डेल्टा एच के लिए आपको डेल्टा यू चाहिए हो। ओके, सो प्लीज रिमेंबर दीज रिलेशनशिप विल हेल्प यू एवरीथिंग। ओके, नाउ राइट नेक्स्ट, relationship between CP and CV. Relationship between CP and CV. देखिए, we all know that delta H is equal to delta U plus delta NGRT, delta U plus what, delta NGRT। ठीक है, अच्छा, if I take for 1 mole of gas, for one mole of gas, it is okay, ऐसे लिख लीजिए, for delta Ng is equal to 1 mole, then we can write delta H is equal to delta U plus RT, डेल्टा H is equal to डेल्टा U plus RT। ठीक है, अच्छा, अब उसके बाद डेल्टा H क्या होता है, सी डेल्टा H अभी हमने बताया, डेल्टा H is equal to CP into डेल्टा T, डेल्टा H is equal to सॉरी CP into डेल्टा T, डेल्टा U is equal to CV into डेल्टा T plus RT। सही है गाइस, ऐसा नो प्लीज टेल मी, इज दैट राइट, ऐसा नो प्लीज टेल मी गाइस।
Yes,
Yes,
sir.
sir.
Now, since the temperature is changing, we can also write this as what, R into delta T, R into the change in temperature, R into delta T, R into the change in temperature, because temperature is changing here. And then what we can do, we can divide by delta T. So if I divide here, I will get CP. If I divide here, I will get CV. And if I divide here, I will get R. And I can write CP minus CV is equal to R. Write this down. CP अपॉन CV भी कुछ होता है ना सर? हाँ, वो स्पेसिफिक हीट रेशियो बोलते हैं उसको, गामा से नोट करते हैं, वो आपके इसमें नहीं है, लेकिन डिनोट दैट बाय गामा, उसको स्पेसिफिक हीट रेशियो बोलते हैं। सबने लिख लिया? ऑल ऑफ यू डन राइटिंग? यस और नो, प्लीज टेल मी।
Yes, sir.
ठीक। Now listen. The complete thermodynamics is based upon what? On the heat exchange, है ना? अभी तक हम लोग किसके बारे में? Heat exchange. What we are talking about? Heat exchange between system and surrounding. Now we just now found out a way how to infer this heat. हम लोग देखिए, if you want to calculate something, if you want to determine something, then you have to, if you want to determine something, you have two ways. You can either measure it or you can calculate it, है ना? If you want to measure something, you need to have a device. If you want to calculate something, देखिए, one thing is calculation will be based upon some measurements. ठीक है? Always calculation will be based upon some measurements, but those measuring devices will be very simple, है ना? And if you want to calculate, then you need a formula for that also. हमेशा याद रखिएगा इस चीज को, and this will help you in many ways. आप like have this picture in your mind. You can either measure something or calculate something. और दूसरा कुछ numerical value निकालने के लिए you don't have any other. For example, एक बार बताइए, आपसे अगर हम लेंथ पूछें, ठीक है, what is the length of this particular line? Then what you are going to do? You are going to measure it using what? Using ruler. ठीक है, तो रूलर हमारा क्या हो गया? डिवाइस हो गया. And what we are measuring the length. But if I ask you to determine the volume, है ना, अगर हम पूछे कि इस क्यूब का वॉल्यूम क्या है? Now, if I want to ask you what is the volume here, वॉल्यूम के लिए आप कोई डिवाइस लेके नहीं आएंगे ना मेजर करने के लिए. What you are going to do? You are going to measure the side length, and then you will use a formula. Volume is equal to the side length cube, if it is a cube, है ना? So volume is equal to side into side into side. ठीक है, तो आप लोगों को दिखा, हम लोगों ने I have calculated a complicated thing, a complex thing using a very simple, using a formula, and this formula uses a very simple device. एक device हमको चाहिए होगा, please remember, device हमको चाहिए होगा, that is ruler here. ठीक है, सीधा सीधा आपको किसी का वॉल्यूम नहीं मिल सकता. You need to have a ruler, simple device, जिससे आप क्या कर सकते हैं? मेजर कर सकते हैं लेंथ, and then you need a formula in order to calculate what? In order to calculate a volume. ठीक है, so whenever you determine something, if you determine some value, you can determine by measuring it, or you can determine it by calculating it. Now, measuring the heat exchange is very difficult. But we all know we can very easily measure what? We can very easily measure the delta T. Delta T को कैसे measure करेंगे? What is the device? Tell me. क्या device use करके delta T measure करेंगे? What device should I use to measure the change in temperature? Temperature कैसे measure कर सकते हैं? बताइए. क्या device use करेंगे? थर्मामीटर. सिंपल है ना? देखिए, आप लोगों ने देखिए अभी फॉर्मूला हम लोगों ने निकाला ना. हम लोगों ने क्या फॉर्मूला निकाला? हम लोगों ने फॉर्मूला निकाला Q is equal to CP into delta T, है ना? where C is a constant. C आपको एक बार पता लग गया, उसके बाद change in temperature करके you can calculate everything. Okay, so we need a very simple device, that is a thermometer, and with thermometer we can infer about the heat. Now heat is a very complicated thing, but it can be inferred from change in temperature, and we are using a very simple method, that is we are using a thermometer. But again, we have two types of heat capacity, and the way it is measured, you can either measure it using a constant volume, or you can measure it using constant pressure. ठीक है, constant volume or constant pressure. Now there are two simple tools or devices to get the exact temperature change. अब देखिए, for example, if there is a system here and there is some reaction happening, and this reaction is giving out heat, and you are putting a temperature, you are putting a thermometer here, and you are measuring the delta T of surrounding. Measure the delta T of surrounding. Now this measurement will not be accurate now, because heat is devolving here also, heat is going here also, heat is going here also, and you have put the thermometer here. So we have to set up a very specific, very precise device so that we can measure the change in temperature of surrounding, so that we can measure the change in temperature of surrounding as accurately as possible. As accurately as possible. So a very simple device that you can make is, for example, this is known as coffee cup calorimeter. Yeah, it is known as coffee cup calorimeter. You just need to have a cup like this. Okay, you just have a cup like this, and in this cup you will add water. And there will be a stirrer. Okay, this stirrer moves like this. Okay, this stirrer moves like this, and then you have some reaction happening inside. Okay, you have some reaction here. This is the reaction mixture. When the reaction will happen, this particular water body here, this water molecules, all of these will get heated up if it is going to give out heat. And you can measure the change in temperature using this thermometer. And why are we using a stirrer? We are using a stirrer in order to homogenize the temperature. We are using a stirrer इस वजह से, क्योंकि मान लीजिए अगर रिएक्शन इधर हो रहा है, तो the temperature is available in all parts of water. एक जगह temperature नहीं बढ़ जा रहा होगा. Okay, so in order to homogenize the temperature, we are going to use a stirrer, and then we can measure delta T using this basic thermometer. Now this type of system, which is used to measure the heat exchange, this is known as what? This is known as coffee cup calorimeter. ठीक है, और heat exchange से at last हमको क्या निकालना? Delta H. Okay, so please write next. Measurement of delta H. All of you understood this? Yes or no? Tell me. The coffee cup कैसे work करता है? हाँ या ना बताइए. Yes or no?
Yes.
ठीक है. Right here. ठीक है, बहुत आसान है ना. You have, अच्छा, you will also cover this cup. ठीक है, you will cover this cup because it is going to be, if you don't cover this cup, this heat will go out. Right, first of all here delta H measurement or measurement of heat लिख लीजिए. A is coffee cup calorimeter. Okay. Make this diagram. अच्छा, एक सवाल हम आपसे पूछना चाहते हैं. इस तरह का अगर कप हुआ, व्हाट डू यू गाइस थिंक? प्रेशर कांस्टेंट होगा या वॉल्यूम कांस्टेंट होगा ऐसे कप में? ये रिएक्शन मिक्सचर है, इतना वॉल्यूम है आपका, है ना? क्या कांस्टेंट होना चाहिए? अगर दिस सेइंग वॉल्यूम. हिबा, जानिया, तारीफ, अब्दुल्ला, आयशा, प्लीज टेल मी व्हाट डू यू गाइस थिंक? क्या कांस्टेंट होगा, प्रेशर या वॉल्यूम? What will be constant? Pressure will be constant in this case, या volume will be constant in this case? क्या कांस्टेंट होगा? जी हिबा, ओके, तारीफ, जानिया, टेल मी क्या कांस्टेंट होगा? प्रेशर कांस्टेंट होगा या वॉल्यूम कांस्टेंट होगा ऐसे केस में? देखिए प्लीज लिसन गाइस, ध्यान से सुनिएगा। यहाँ तो वॉल्यूम इसका बढ़ सकता है ना, हाँ या ना, स्पेस है मौजूद, वॉल्यूम तो बढ़ सकता है। दिस इज द रिएक्शन मिक्स जहाँ पे रिएक्शन हो रहा है। इफ इट गेट्स हीटेड अप अ बिट तो उसका वॉल्यूम तो थोड़ा बढ़ सकता है ना, देयर इज सम स्पेस। बट अगर आप ध्यान से देखें, सो दिस इज जस्ट अ कॉफी कप, यहाँ पे प्रेशर का यहाँ पे मेंटेन करने के लिए कुछ नहीं रखा हमने। सो वी विल एक्सपीरियंस 1 atm pressure overall. What pressure are we experiencing? We are experiencing 1 atm pressure. Can all of you see that? Yes or no? Please tell me. हाँ, फहद, हिबा, क्लियर है?
Yeah.
है ना? तारीफ, what about you? So this is at constant pressure.
sir.
Please write. फहद आप बताइए, क्लियर है? यस फहद? फहद को क्लियर नहीं लगता है। हाँ फहद क्लियर है? अच्छा, थम्स अप करें, नोटिफिकेशन नहीं आता, हाँ ना बोल दीजिए, मतलब इतना ज्यादा क्या आप लोग एनर्जी सेव करते हैं? फहद बताइए, क्लियर है नहीं क्लियर है?
Clear.
थैंक यू वेरी मच। So what does it measure? It measures QP, and QP is equal to what? Delta H या delta U? बताइए। Heat exchange at constant pressure is equal to delta U या delta H? ओहो, फिर से इतना टाइम लगा रहे, इतनी
H,
दफा।
H, H.
हाँ, डेल्टा H। बना लिया होगा सबने? राइट, नेक्स्ट B part. Okay, so in B part we are going to measure the heat exchange at constant volume, and we use for this bomb calorimeter. Okay, now I'm pasting the diagram. I will explain the diagram and then you are going to write. ठीक है, ये तो आप लोग को पता ही है कि this is used for the measurement of heat at constant pressure, sorry, heat at constant volume, that is delta U. Now please see here guys. Now bomb calorimeter में क्या होता है? सबसे पहले देखिए, you have this tanker here. Okay, you have this tanker here. This tanker has a constant volume, और यहीं पे आपके पास पूरा सैंपल है. Okay, here only you have the complete sample, and this is the volume that you have, and this complete gas chamber, it is filled with oxygen. It is filled with oxygen. ठीक है, you have the gas chamber, इसको fill कर दिया किससे? ऑक्सीजन से, and here you have the sample. This is your sample. Sample को क्या करते हैं? Sample को हम लोग जलाते हैं. Okay, we start, we fire here. All of you have seen those patafa, na? Patafa mein you have that Lect, this thing. So this is the firing lead. Okay, this is the firing lead for the pataha, and this is the firing lead for this bomb calorimeter. ठीक है, देखिए बॉम्ब है, वो भी आपको वहां पे क्या होता है? बॉम्ब होता है. So these are the firing leads. You fire this up, this will go down, and this will heat this sample up. And since you have oxygen, combustion will take place. What happens here? Combustion take place. सबसे पहले देखिए क्या होता है? Combustion takes place. Giving out हीट। आपको क्या मिला यहाँ से, कंबशन हुआ तो यू गॉट हीट हियर, ठीक है, आपको हीट मिला। अब ये जो आपके पास चेंबर है, this part here, this is a diathermic wall, and this diathermic wall, it gives out heat towards this water. And here you have the stirrer. Stirrer is used to homogenize the temperature. And when you get an increase in temperature, the thermometer will show the increase in temperature. So first of all, combustion takes place giving out heat. The temperature of water rises, and with this what we measure the delta T. We'll write here, measures heat at constant volume. QV is equal to delta U. So this measures बॉम्ब कैलोरीमीटर क्या मेजर करता है, अब देखिए आपको बोला जाएगा बॉम्ब कैलोरीमीटर में मेजर किया हमने, एंड वी फाउंड द हीट एक्सचेंज टू बी, द हीट ऑफ कंबशन टू बी दिस मच। तो क्या बता रहे हैं वो, दे आर टॉकिंग अबाउट डेल्टा यू, ठीक है। सो बॉम्ब कैलोरीमीटर भी मतलब डेल्टा यू, प्लीज रिमेंबर दिस, बॉम्ब कैलोरीमीटर मीन इट इज डेल्टा यू। All of you done, yes or no, please tell me. Please tell me yes or no.
Yes, sir. Done.
एक सवाल लिखो, 1.25 ग्राम of octane octane का मतलब C8H18, 1.25 gram of octane is burnt in excess of oxygen. Is burnt in excess of oxygen in a bomb calorimeter. The delta T was from, the change in temperature was from 294 Kelvin to 301 Kelvin. The heat capacity of bomb calorimeter and its content is 8.93 kilojoule per Kelvin. Calculate the heat transferred to the calorimeter. Please listen here, guys. सुनिए, ये था आपका सिस्टम, this was your surrounding, it will give out some heat and this is the heat that we have to measure. Now since it is bomb calorimeter, तो बताइए constant pressure या constant volume, constant pressure या constant volume, tell me guys.
Volume.
Constant volume. So QV is equal to, heat capacity की बात कर रहे हैं तो क्या मिला हुआ है हमको, CV into delta T. यस और नो? सही है?
Yes, sir.
हाँ ना? हाँ ना, जल्दी बताइए। कैलकुलेट कर लीजिएगा। Plug in the value of CV, plug in the value of delta T, you will get Q. All of you can do, yes or no, tell me.
Yes,
फहद,
sir.
हिबा, है ना? तो देखिए इक्वेशन आपको देखने का है, Q भी है या C भी है या क्या है, दैट्स इट। फहद करेक्ट, वेरी गुड। कांस्टेंट वॉल्यूम या कांस्टेंट प्रेशर, कांस्टेंट वॉल्यूम या कांस्टेंट, इसी इसी के बीच आप लोग इंटरव्यू करिए। ओके, कांस्टेंट वॉल्यूम और कांस्टेंट प्रेशर। यस हिबा, वेरी गुड, करेक्ट। बाकी लोग आंसर दीजिए प्लीज। आयशा, तारीफ, अब्दुल्ला। मल्टीप्लिकेशन में इतना टाइम लगाते हैं आप लोग। I'll wait 2 more minutes. Fahad and Hiba, please write this question. No, Mohammed Tari, that is wrong. Send your answer on my WhatsApp, Tari. Tari, send your answer on my WhatsApp. I want to see what you have done. हाँ ना, कुछ बोलिएगा तारीफ। हाँ भेज रहे हैं सर, यस और नो। यस तारीफ।
Sir, I can't send now.
हाँ
Can
तो
I send
बोलिएगा
after
ना
some time?
आपसे तो।
Wait, sir, I'll recheck into.
No, 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 no. Tell me what is CV. Tell me what is CV.
CV 8.93.
8.93 पूरा पढ़िए ना, पूरा पढ़िए। इतना क्या
Sir,
तकलीफ है?
8.93 kilojoule.
हाँ तो कितना हो जाएगा? 8.93 into 1000, right? Yes or no?
Yes, sir.
Into what is the delta T?
Delta T 301 minus 284.
How much it is? What's the value? 301 minus 294 will be equal to how much? Subtraction में इतना time लगेगा. Tareef. How much? Tareef, what will be this value?
7.
How much?
7.
हाँ, ठीक से बोलेगी है ना? 7. Yes, I think 7. This will be Kelvin. So Kelvin and Kelvin will cancel each other. I think there is no need to convert this. So you will 8.93 into this will be just kilojoules into 7 kilojoule. 7 threes are 7 threes are how much? Tareef, keep your mic on.
21.
7 nines are
7 9 63.
63 plus 2
65.
7 eights are
56.
56 plus 6
62. So 62.15.
51 kilojoule.
Yes, sir.
Okay, please remember half marks is deducted in CBSE board for no units or wrong unit. ठीक है, ध्यान रखिएगा इस बात का. Half marks is deducted. It was such a simple question. ना आयशा का आंसर आया है ना? आयशा तो क्लास में है ही नहीं. ना जानिया का आंसर आया है. Write this question, guys, all of you. See, 1 gram of graphite is burned in a bomb calorimeter in excess of oxygen at 298 Kelvin at 1 atmospheric pressure, according to the equation this much. Okay. Now, in bomb calorimeter, that means it is what it is going to be. QV is equal to CV into delta T. We are calculating the heat exchange at constant volume. Heat exchange at constant volume. Now, 298 to 299, that means there is a change in temperature of how much? 1 degree or 1 Kelvin. Okay, this the change in temperature is 1 Kelvin. And the CV is equal to 20.7 kilojoule per Kelvin into 1 Kelvin. So Kelvin will cancel. And QV will be equal to 20.7 kilojoule. ठीक है? So this is the heat transferred to the calorimeter. तो calorimeter में आपके पास इतना heat आया है. ठीक है? Please remember that. But if you want to calculate the delta U, है ना? अगर हम QV की बात करें सिस्टम के मुताबिक, so tell me the system is giving energy or taking energy? System is giving energy, yes or no? तभी तो टेम्परेचर इंक्रीज कर रहा है सराउंडिंग का. इज दैट राइट? हाँ या ना बताइए.
Yes, sir.
है ना? दैट मीन्स दिस विल बी, इफ आई टॉक अबाउट डेल्टा यू, दिस विल बी इक्वल टू माइनस ऑफ QV, which is equal to minus 20.7 kilojoule. If I'm talking about the internal energy of the system, so delta U will be equal to what? Minus 20.7 kilojoule. Everyone is okay with this? Yes or no? Please tell me. Hi, Anna. Is minus sign sab okay?
Yes,
Na? Fahad, Hiba, tell me, guys.
Yes.
Now, delta U will be equal to minus 20.7 kilojoule. Now, what they are asking? They are asking, what is the enthalpy change? क्या पूछ रहे हैं वो? They are asking the enthalpy change for the above reaction at 298 Kelvin at 1 atm pressure. Now please see. How many moles of graphite are we using? How many moles of graphite are we using in this particular equation? 1 mole, right? Yes or no? Yes or no, guys? 1
Yes,
mole.
sir.
ठीक है. Now, you see, if I am for combusting what 1 gram of graphite, we are having for 1 gram of graphite. Carbon's molar mass is what? 12 grams per mole into minus 20.7 kilojoule. This much energy will be given. This is much energy is given by what? 1 gram. This much energy is given by 1 gram. If I talk about moles, I have to multiply this by the number of moles. So grams and grams will cancel each other, and we will get this as minus 2.48 into 10 to the power 2 kilojoule per mole. 7 twos are what? 14. So this is what 12 into 20.7. Okay. So we'll get this as 2.48 into 10 to the power 2 kilojoule per mole. And this is what, this is your delta H for the reaction. Okay.
So लेकिन delta U equals to delta equals to QV होता है ना, माइनस क्या है?
वही तो हम बोल रहे थे ना, डेल्टा यू तो इंटरनल एनर्जी है, राइट? डेल्टा यू इज इंटरनल एनर्जी, राइट? ठीक है. इंटरनल एनर्जी क्या होगा? नेगेटिव होगा या पॉजिटिव होगा? अगर हीट बाहर निकल रहा है सिस्टम से तो
नेगेटिव
है ना, तो बस वही नेगेटिव है यहाँ पे, सही. ठीक है. देखिए, see what we have done, we have burnt 1 gram of graphite. ठीक है, we have burnt 1 gram of graphite and we have got the values for them. And the questioner is asking what is the enthalpy change for the above reaction. Experiment के बारे में नहीं पूछ रहा. This is another thing that you have to always take care, whether it is asking about the experiment or it is asking about the reaction. So when it is asking about the reaction, so we have to calculate for 1 mole of carbon atom, for 1 mole of carbon atom, and that is why for 1 gram of graphite अगर हम बात करें, इसको मोल्स में अगर कन्वर्ट करना है, then I will multiply it by the molar mass of the carbon atom, that is 12 grams per mole. So grams and grams will cancel out each other, and we will get what? We'll get the delta H, that is equal to minus 2.48 into 10 to the power 2 kilojoule per mole. This will be enthalpy of the reaction. Why? Because what is the change in the number of moles of gas यहाँ पे? This is graphite. This is graphite is solid, oxygen is gas, carbon dioxide is gas. So number of moles is equal to product minus reactant. In product we have 1 mole. In reactant we have what? In reactant also we have 1 mole. So delta Ng is equal to 0. When the number of moles of gas is equal to 0, delta H and delta U are equal. So ये तो हमने क्या calculate किया? This is actually this is delta U, क्योंकि we are calculating it from minus 20.7 kilojoule. ठीक है? Minus 20.7 kilojoule into 12 grams, that is going to give you delta U. But delta U is also equal to delta H, because please write here, delta H is equal to delta U. For 1 gram of graphite, delta U is equal to this much, delta H to delta U, as delta Ng is equal to 0. ठीक है? Please write this down. ठीक है? This is important that you differentiate between the reaction. If you are talking about reaction, then it will be always in terms of moles. Okay. And if you have anything that is given with respect to experiment, then experiment will be in terms of mass. Experiment will be generally in terms of mass, but reaction will be always in terms of moles. Because whenever we write reaction, for example, carbon plus O2 is giving you CO2, then this is 1 mole of carbon reactions, 1 mole of oxygen gives you 1 mole of carbon dioxide. If you have H2 plus O2, gives you H2O. Then he will write 1 mole of hydrogen reacts with half mole of oxygen to give 1 mole of H2O gas. Okay, so all of these reaction type of question, and in more detail we will study in the next class. We'll also talk about thermochemical. अभी तक तो हमने chemical equation पढ़ा था, right? And in the next class we will talk about the thermochemical equation. देखिए, for example अगर हम इस equation की बात करें, carbon plus oxygen is giving you carbon dioxide, but ये सिर्फ carbon dioxide नहीं देता है, it also gives you heat ना, तो heat भी तो product है. Once you add the heat part here, that is delta H is equal to minus 2.48 into 10 to the power 2 kilojoule per mole. Now this becomes thermochemical equation, जहाँ पे आपको ये भी पता है कि heat is also being released. Negative sign है मतलब heat is being released. If you have positive sign, that means heat is being added. ठीक है, तो heat आपको या तो reactant में हो सकता है या तो product में हो सकता है. If it is in the reactant, that means we are adding heat as a reactant for the reaction to happen. If the heat is in the product, that means अगर heat emit कर रहा है, exothermic reaction है. In that case, we will say that heat is as a product. ठीक है, चलिए, all of those things will be later on, but ये थोड़ा सा introduction था जो भी हम लोग आगे पढ़ने वाले हैं. At why it is different when you have reaction, because जब reaction की बात करते हो तो आपके पास 1 mole of carbon 1 mole of oxygen इस तरह से बात करते हैं. Okay, write this down, let me know once you are done, and then we will close this class. Please आप लोग जो भी पढ़ाते हैं हम at least do the same questions at least on your own, है ना? कम से कम वो सारे सवाल जो आपके पास नोट्स में है वो खुद से आप लोग एक बार ट्राई करके देखिए बिना आंसर देखे. थिंक इन दोस टर्म्स की कांस्टेंट प्रेशर है या कांस्टेंट वॉल्यूम है तो डेल्टा एच होगा या डेल्टा यू होगा, और अगर डेल्टा एन जी 0 है तो एच और यू दोनों बराबर होंगे. थिंक इन दोस टर्म्स एंड देन रीडू ऑल द क्वेश्चंस. ओके, ऑल ऑफ यू डन? यस और नो, प्लीज टेल मी. ऑल ऑफ यू डन? नॉट डन?
Yes, sir. Done.
Just a second. Okay. हाँ, डन गाइस, देख लिया.